Hey guys, in this STEM activity, we're going to be making our own lava lamps with hustle materials. But before we do so, I want to explain to you a little bit of the science that goes behind making a lava lamp. You need two basic scientific principles, and those will be density and polarity. Now, what is density and what is polarity? Well, density is the measurement of how compact a substance is. So in other words, how much of it fits in a certain amount of space. That space is known as its volume. Now, the volume is the amount of space an object takes up. So if an object is hollow or empty, volume is the amount of water it can hold. Polarity, on the other hand, is a feature of chemical bonds. So what that means is that two different atoms in the same molecule do not share electrons equally. So look at the water molecule. In the water molecule, you can see the two hydrogen atoms and the oxygen atom. Okay. At the end of this molecule, you can see that the hydrogen atoms contain the positive charge, and on the other end, the oxygen contains the negative charge, thus allowing polar molecules to mix with each other and interact. Nonpolar, though, means that they are not attracted to water because the electrons of those atoms are shared equally. What that means is that they don't have a positive nor a negative charge. And this is why water and oil don't mix. So, go back to the water molecule. If this was a non-polar molecule, that would mean that there will be no charge here and no charge there. So, think about it like a magnet. Okay? Where north poles and south poles attract each other, it's the same thing with polar molecules. The positive end of the water molecule will connect with the negative end of the other molecules. Okay, so if you measure an equal volume of oil and water, you will find out that the cup of water actually has more mass than the cup of oil. And that's because water molecules are packed more tightly together. What does that mean? Well, it means that water molecules are more dense. And the more dense the liquid is, the more it's going to sink. So take a look at this example lava lamp. At the bottom you have the water, at the top you have the oil. Flip it over, water stays the same, still more dense than the oil. So it's always going to sink to the bottom. Okay? Another way to look at it is polar molecules love water. Non-polar molecules don't. And that's the simple science for a lava lamp. Now, in a real lava lamp though, polar and non-polar liquids are used just like in ours. However, the densities of these liquids are closer together to each other. Okay? So the denser liquid is gonna sink to the bottom, down there, where it's gonna be heated up by a light bulb. The light bulb will then expand that substance. It's going to help it rise up because remember, the hotter the liquid or the substance, the less dense it is. And if it's less dense, it goes back to the top. So again, the light bulb is going to heat it up, expand it, cause it to go back up, raise, where it's going to get compacted again. It's going to cool down, become more dense again, and then sink right back down, thus recreating the cycle. In our lava lamp though, we use Alka-Seltzer tablets that are gonna react with the water to produce something called carbon dioxide gas bubbles. These bubbles are gonna stick to the water, creating a water-gas combination, which is gonna become less dense than oil. Therefore, since it's gonna be less dense than the oil, it's gonna go up, right? So this water-gas combination of bubbles is gonna go to the top, it's gonna rise, where they're gonna pop and escape into the small amount of air that you have allowed inside the water bottle. Once that happens, once the bubbles pop, it's gonna allow the dense water to sink right back down to the bottom. So I'll demonstrate real quick for you. Now, I don't have Alka-Seltzer tablets anymore, but I have sodium bicarbonate, which is what Alka-Seltzer has in. So it's gonna take a little bit longer to sink, and the reason for that is because the tablet is more dense than powder, right? But there you go. You can see the reaction. Bubbles pop, and the dense water goes back to the bottom. There you go. That's the simple science that goes into making a lava lamp. Now, go ahead, try it for yourself. And while you're doing this experiment, just think about the scientific principles that are being observed. Ask questions and predict. Think about other non-polar liquids that you might know about, other things you can mix with water, things you can add, make observations, and try it again.